Hi everyone, so welcome back to Codera. In this video, we'll discuss the problem B from the latest CodeForces educational round 116. So let's read the problem statement. So the problem says that in the Berlin State University, you have received an update of the new update of the operating system, and initially it is installed only on the first computer. Okay, so let's say there are a number of computers. So initially the update for the operating system will be installed only on the first computer, and the updated file should be copied to all the end computers, right? The computers are not connected to the internet, so the only way to transfer updated files from one computer to other computer is to copy them through a cable, right? And using one cable you can you can push the update from one computer to another computer in 1 hour, right? This is also something that has been given to us. So using one cable you can only update one computer from an updated computer, and it will take 1 hour. Your task is to find the minimum number of hours that you will require to copy paste the update to copy the update to all the n computers where only k at maximum only k cables will be available at a particular point of time. Let's say you have more number of computers that are updated than the value of k. So in this case n minus k computers will not be able to provide the updates, because there can be a maximum of only k possible k cables through which the updates can be transferred from one computer to from an updated computer to not updated computer, right? So let's say if I was given n is equal to 8, looking at the test case, if I was given at n is equal to 8 and k is equal to 3, so the number of computers was 8 and k was equal to 3. So what I'll do is, in the first hour we can copy the update from the first computer to the second computer, and in the second hour what we could do is we can copy the update from the first to the third computer and from the second to the fourth computer, right? So now we have four computers updated. Now in the third hour we can copy from first to fifth, second to sixth, and third to seven. Now you will say that after the second hour we had computer number 1, 2, 3, and 4 which could provide updates, but why didn't we use four computers in the third hour? So the reason was that we were bounded by this constraint. The cable was only three, although the updated computers were four, but only three cables were available. So this is why in the third hour we can only update the three computers, right? In the fourth hour we can copy the update from one computer to the last remaining computer, and in this way we can update all. Like if I'll just show you like how we can actually do it. So what will happen is, let's say from this test case I was given n is equal to 8 and k is equal to 3. So initially the update will be provided to the first computer, right? So from the first computer what I'll do is I'll provide the update to the second computer, right? From the first computer I'll provide the update to the second computer. So during the first hour what will happen is, now two computers are updated, right? Two computers are updated with the latest software, because one was already updated, and after the first hour one more computer has got updated. Now second hour, during the second hour what can happen, now you have two computers, they can now they can update two more computers, right? So now 3 and 4 will let's say computer number 3 and 4, so they will get updated through these cables, and we can use two cables because at max we can use three cables, right? So after one more hour what will happen, total four computers will be updated, right? Notice that notice one more thing, that if the cables are available, uh, if the cables are available if the cables are lesser than if the updated computers are lesser than the cables, so each hour you will be doubling your updated computers, right? Let's say if I'll tell you for once we will see this case also. For the third hour what can happen is, you can see that I have this. Okay, so in this hour what can happen, I let's say I have three more computers. Okay, the computers are named as 5, 6, and 7. So here what I can do is I can take one to update this 5, 2 can update this 6, let's say this 3 can update this 7, right? So if we had number of cables such that if we have a situation where the updated computers are lesser than the number of cables, then each time your updated computers will be doubling. Okay, updated computers will be doubling, because if in case if four cables were available, if instead of this three, four cables were available, then the computer number 8 could have been updated by this computer 4. But since you are bounded by this constraint that you can only use 3 cables maximum. So that is why, since you have been given only 3 cables, so this is why what you will do is your k will be 3 and you cannot update more, right? So now what will happen, now 7 computers will get updated. Notice that what I have told you, if the cables if the number of updated computers were lesser than the number of cables, then each time your rate was doubling, right? You can see from 2 to 4. And if here 4 cables were present, that is the updated computers were lesser than the cables, lesser equal to cables. So in this way what would have happened is you would have got 8 computers updated in the third hour itself. But since you could not do this, so in the fourth hour what you will do is you will pick one more computer. Now all these updates are done after the third hour, so what you will do, only one computer is left to be updated, this computer number 8. You will update this with this computer number 1. So you can take any computer of your choice. Okay, so 8 computers will get updated, right? So what will happen, if you have a situation such that the updated computers are lesser than the k number of cables, so each hour after each hour passing you will be updating double, right? If you have, let's say, 2 computers updated, so 4 will get updated, and similarly 8 after 1 hour, right? This is what can happen. Now next up, another thing that you need to notice is, what if that is not the case? So in that case what will happen, the total number of total time that you have taken so far, let's say that the updated computers are more, right? So when the updated computers will be more, so in this case you can see that this computer was left, right? So what you will do is, the total number of computers total will be the hours that you have spent up till now. But besides this total, what will happen with this total, you have to add another amount, and you have to, let's say you have to add x. Okay, what is x? X is nothing but the more amount, the amount that you, the number of computers that are still left to be updated. So in this case what you will do is, in this case you can only update k computers per hour, right? So you need to take a seal. So for taking the seal, I'll add k minus 1 to this because I want to take the seal. So let's say I was 3 and I had k is equal to 4. So in this case you can see that it will give me 0 point something, but this will not give me an integer answer. So I will just update it with k minus 1, that is I will add this with 3 and my k, let's suppose, was 4. So in this case it will be 6 by 4, which will give me a 1, right? So in this case I can get the seal of it, right? So 3 by 4 was giving me 0.75, but now it is giving me 1. So this is how it will help me out. Now what will happen, the x amount will be nothing but k minus updated laptops, and to take the seal I have added k minus 1 to it as well, and I have explained it here. So basically you need to add this amount x, which is nothing but the number of computers that need to be updated, that is n minus updated number of computers, and you take the seal of this dividing by k, and in this way you can get the number of computers that the total number of hours. So up till now, that optimally you took total hours multiplying 2 at every hour, because if your updated computers were lesser than the cable, so at each hour you will be doubling your updated computers. But if that was not the case, then all those computers that have been left, so you will just update them, right? So let's suppose that only one computer was left to be updated and k was 2, right? So you will divide this by k is equal to 3. So you can see that one more computer gets updated, right? So you can see up till here 7 computers were updated. Up till here the total time that you took up till here was 3, and you will add one more hour to it, right? So x value is 1, right? So you'll add 1, and the total time that you had taken up till now was 3, and you'll add 1 to it, so the final answer will be 4 hours, right? So this is similarly you can try out for all the test cases. Now I want to show you the code part for my implemented code for this. So what I have done is, basically this is a simple problem. So I have taken n and k, that is the number of computers, and k. Then I have initially I have one updated computer, because the first computer will be updated, and the total hours I have taken result is equal to 0. After, at each hour I'll check that if my updated number of computers is lesser than k, that means that every time I'll be updating the double number of computers. So if I have updated computers which are lesser than the cables, if the updated number of computers are lesser than the cables that are available, so that means that after each passing hour I'll be doubling the number of updated computers that I have, right? So I'll be updating my updated with the multiplying that by 2, and if the updated number of computers is less than n, that means that still there are computers that are left that need to be updated. So the total time that I have taken, total number of hours that I have taken up till now, I'll add it with n minus the updated number of computers, so the number of computers that I want to update, plus I'll add k minus 1 to take the seal when divided by k, and this will be the number of hours that I'll need to take extra to update all the computers. Otherwise, if I have already reached the number of updated computers that were required, so I'll simply print the number of hours that I have taken up till now. Okay, so this is the code for this problem. In case if you have any doubt, so you can mention that in the comments and I'll reply to them as soon as possible. Make sure to like the video and subscribe the channel, because we bring more such videos related to competitive programming contest on CodeForces and atcoder. Thank you for watching.